So stepper motor is a DC motor in which you are having the poles. These are the electromagnets. Those are called the poles. You are having pairs of poles A, B, C, D. So there are 4 poles in this particular stepper motor. And then you are having the permanent magnets mounted on the stepper motor. You are having 1, 2, 3, and 4. So these will not be in equal numbers. This will be one difference will be there. There will be a difference of 1 pole between the stator and the rotor. So here you are having 4. Here you are having the 3 pairs of magnets. Now difference between them will be the step angle. At what step angle you can rotate. Now you can see we are supplying current to A here. You are supplying current to A. So this particular magnet is going to align along A. This particular magnet is going to align along A. Now next one is you switch off the power to A and you will apply power to B coil. Then what happens? When you are applying power to coil number B, what happens is going to align along this particular direction. So it is going to align along this particular direction. So you will be having a rotation in the clockwise direction. Next, you are trying to apply the current to coil number C. Then this 5 will be shifting to here and it will be aligning along that particular direction. Then again you are applying D. Again the next coil or the next magnet is going to rotate and you will get the alignment. So in this way, the rotor will be moving from one position to another position, one position to another position continuously based on the current you are supplying. So this configuration is called as a permanent magnet stepper motor. It is called as a permanent magnet stepper motor. Why it is called permanent magnet? Because the rotor here is made up of permanent magnets. The stator is made up of coils. Now you have to turn on and turn off the coils in a proper fashion. Then only the rotation is going to take place. You cannot turn on and turn off in any fashion. So whenever we say a stepper motor, it will require a separate drive circuit which is going to switch on and switch off the different coils so that you are going to get the continuous rotation. If you are directly supplying the DC supply, what happens is coil A is energized. If you are continuously supplying DC without doing any changes, then the motor is going to remain in this particular position and it will not rotate. Even though you apply some amount of force, it is not going to rotate. That is called as stall torque, which means it is going to hold its position when you are applying the current. And that stall torque can function like a brake. You want to hold the object or you want to hold a robotic arm in a particular position, then if you just have to apply the current voltage, then as long as the current is flowing, it is going to maintain its position. Even though you apply some load, it is not going to rotate by any value. Now what is the disadvantage of this stepper motor? If you are trying to rotate the stepper motor at high speeds, instead of moving by a fixed value, it will have some slippages. So you are expecting one step. So this is a step angle. You want it to rotate by one step, but it will rotate by more angle because it is not able to stop. So actually you give one pulse, it is going to rotate by step angle. Another pulse, it is going to rotate by one more angle. So actually what is happening is, it is starting to rotate, it will stop. Again it is starting to rotate, it will stop at that particular position. But at high speeds, it is just like putting a brake to the automobile. You are trying to drive the automobile at a very fast speed. Suddenly you try to apply the brake, what happens? The vehicle will continue to move forward. So because of the rotational inertia at high speeds, it is not able to take the proper number of steps. So there will be something called as a slip, because of which we are not able to control the position accurately. But at a low speeds, it is very easy to control the position defined by the step angle. If you supply 4 pulses, it will rotate by 4 step angles. If you know what is the step angle, then you know how much rotation has taken place. So that is a permanent magnet stepper motor. The next one is a variable reluctance stepper motor. The next one is a variable reluctance stepper motor. So in that what happens is, instead of having a permanent magnet rotor, you are having a soft iron core rotor. You are having a soft iron core rotor. Then instead of applying the current to one coil, you may be applying to 2 coils simultaneously. Then the rotor is going to move here in between the 2 coils. Then you are switching off one coil, then it will further align along this particular direction. So instead of having a permanent magnet, you are using a soft iron core rotor, and by controlling the power to the various coils, it is possible to make the rotor to rotate continuously. So that is a variable reluctance motor. Then you are having a hybrid stepper motor in which you are going to get very fine